Here's integrated 3. It's CL1-114. It says create a complete graph of f of x equals x squared minus 2x minus 8 and fully describe it. So we have to remember what a complete graph, what they mean, and we have to fully describe it. So I think a complete graph needs to have the intercepts, like the x and y intercepts, and it needs to have, this looks like a parabola, so I'm going to have to get the vertex. And so we'll go ahead and start with making our graph, and then once we have the graph we can describe it. So in order to get the x and y intercepts, I know I can get the x-intercepts if I let y equal 0, and I know I can get the y-intercept if I let x equal 0. So it's easy for me right here to let x equal 0, because if I put in a 0 for these x's, then I'm just going to get, trying to cover that up, negative 8. So I know that the y-intercept is going to be at negative 8. So it'll be like 0, negative 8. So I want to remember to put that point on there. I need the x-intercepts. So I saw some of you guys, you could make a table and plug some numbers in and try to get them. But I think the easiest way to get them is just to set this equal to 0 and solve it, because it's a quadratic and that's what you guys were born to do. So we're going to find the intercepts. I'm going to solve my quadratic by factoring, but if you wanted to use another method like complete the square or what's the other one, or quadratic formula, you could use that. I'm going to show a little bit how to factor. I think many of you already know how to factor, but you take you make an area model box, and then you put the x squared, you put the squared term down here, bottom left, you put the constant top right, and then what I do is I multiply them, like, and I put them in the top right here of my diamond. This thing, we call it a diamond problem, because it's supposed to look like a diamond. So I've got x squared times negative 8, that's negative 8x squared. So I need to find some numbers that add up to negative 8x squared and that multiply to make negative 2x. And so I already did this. Like, I figured out stuff that multiplies to make 8. I know 4 times 2 makes 8. If I use negative 4 and positive 2, then these two are going to add up to make negative 2, and they multiply to make negative 8. So then I put these two numbers that I found in my box. So I'll put the negative 4, and it doesn't matter where you put them. Like, I could have put the 2x up here and the negative 4 down here if I want to, and you'd get the same, it'd still work. Okay, so now I want to, on the outside of here, I want to get my factors. So this is an area model box, which means length times width equals area. So this, to get x squared, it had to be x times x. Now this one is x, because see that side right there, that's side length is x, and across the bottom would have to be 2 for it to multiply to make 2x. So I'm going to put a 2 here, and then this is from here to here is x, so that means this is also x. So x times something equals negative 4, so I know that's, or sorry, equals negative 4x, so this is x minus 4. And then I can check, does negative 4 times 2 really make negative 8? And I see that, you know, it does. My area model box works, so I'm going to write it in factored form. Because the whole reason I got into this is I'm trying to find my my x-intercepts. So you let y equal 0 to find the x-intercepts. That's why we're doing this. And so now I'm using zero product property. If this thing times this thing equals 0, one of the two things has to equal 0. So I'm going to set them each equal to 0. And solve each of them. So this is going to be x equals 4. Normally I don't show all this much work, but in case there's anyone that doesn't know how to do it, I'm just showing the whole thing. So that's where my x-intercepts are going to be. So that means I have an intercept at 4, 0 and -2, 0. So to make a complete graph, I need all the intercepts. So I have my y-intercept and I have my x-intercepts. So I'm going to just go get out my graph now. So I'll just get some paper and draw a graph on it. And I'm going to put my y-intercept, what did I say it was? -8. And I'm going to get my, did I say x? That's my y-intercept. My x-intercepts were 4 and -2. Okay, and now I'm going to need my vertex, because you'll see there's not a, if I just assume that's my vertex, I'm going to have a wonky looking graph. So the way you guys were taught to find your vertex is, you know that a parabola is going to have symmetry. So you can just find out what's the halfway point in between these two. Like we've got 1, 2, 3, 4, 5, 6. So I think this right here, just by looking at it, this is exactly halfway. Like if I'm going to achieve symmetry, my axis of symmetry has to be at x equals 1. Okay, that was a simple graphic way to do it. And so I know that my vertex has to be on this dotted line somewhere. So since I know that, I can plug that into my equation. Okay, so let's do that. So I know that the x-coordinate of the vertex is -1 because it has to lie on the line of symmetry. Sorry, not -1, +1. So I'm going to go so 1 squared is 1 minus 2 minus 8. So I've got 1 minus 10, I got -9. So that tells me that if that's -8, that's -9. This right here, that's my vertex. And then if I want to just, I know it has symmetry like this. And then don't laugh at my drawing, but I'm going to try to draw it. I'm going to try to, it's not going to be pretty, but I'm going to do my best. Just do your best when you're drawing them. I'm putting arrows on them, and try to draw your parabola. That's good enough. It has all the parts that you need. I'm scaling by 1. If I wanted to, I could go in here and give some ordered pairs. My vertex is let's see, it is 1, -9, and then this is 4. Something like that. So there's my complete graph. Oh, this is a long video. And then we're going to describe our graph completely. So we can do that pretty fast. The shape, it's shaped like a parabola. I'm just going to say it's a parabola. And it opens up. Oh, I think that's another question. I shouldn't have written that because I think they ask us that later. The line of symmetry is, I'm going to say at x equals 1. So all these, where did I get all this? Off that, there's a sign that someone of you guys made, how to describe a graph. And so I just wrote down everything that was on that little list that was on the wall on describe a graph. So that's where I got all this. So it opens up. So I'm going to say up And then asymptotes, I'm going to say no. I'm going to say it's increasing. Oh, I should have said, well, it's increasing for x is greater than 1. Because see, this part of the graph where the 1 is increasing, but it's decreasing for x is less than 1. X and y intercepts, I wrote those all down. We're going to have 4, 0, negative 2, 0, 0, comma negative 8. Domain and range. Domain is all real numbers. And I can tell that it's all real numbers because I just look and these have arrows and they go out to the sides, so I know. And then the range, is that y is greater than or equal to negative 9 is the lowest point. So, okay, and then the endpoints, no. Vertex is a minimum point at 1, comma, negative 9. Continuous, and it's a function. Okay, I better cut this short. And that's all I got.